Hey, what's going on, guys? Again here. In this video we're gonna write a core routine of the entire operating system shell loop. The search routine, so the one would be allowing us to answer the simple question whether the certain file name is available or not to run. But before that, I just want to make a quick recap of what we've done so far, because I came up with an interesting design solution. I just want to show you that. So in the last video, we've coded a routine to print the list of all the games available, but I've realized that it really, I don't really want this to be the part of the shell itself, and instead we would be able to write to form it as a simple app, which would be kind of running in the boot sector, just like the boot sector games on their own. So I don't really want to pollute the shell file with all of this stuff. I'm not going to be removing it in this video in particular. I'll come back to that later. But I've realized that commands like list, or I can even go for Linux type like ls and things like that, but it doesn't matter how to call the commands. So the commands are literally would be treated as the games, and the matter of having the additional functionality to the operating system, like having a look at all the games available, potentially deleting the games, like remove, and then specifying the sector where you want to remove that and things like that. This might be on the cards, and also this allows us a bigger scope, like let's say for every single file name, we can print the associated sector. So if we have the entire 512 bytes for that, that would be much better, like more space to implement that as well. So that's just a bit of a plans for the future. Okay, and yeah, by the way, this is the output from the previous part what we have. So let's actually go, and now we have everything to implement our search routine. So without further ado, let's actually start. Okay, I will start by, I've adjusted the indentations for the commentaries, by the way. So let's get rid of all the necessary stuff that we don't need from the previous demonstrations. So let's run this again, and now we are within our loop. Great. So print files, yeah, so this print files, so just mention this here, would be moved to a separate app later on. So just to give you an idea, so it's not going to be here and here. Instead, I want to create a search file procedure. So search file procedure and search file. That's pretty it. Okay. Okay. So at first, I want to answer the question whether the user did actually make whatever input or not. So I can say compare the byte at the user input, okay, with a 0. So if he didn't input anything, in this case I want to return from the search file. So jump equals and this return, okay, and here we'll have the return label and just return. So want to return to main OS shell loop. All right, great. So now within the OS itself, not the search game, but let's call it search file, because there will be not only the games, but the files for commands, etc. So search file, and so yeah, now it's not going to be visibly doing anything, but yeah, we just really want to make sure that if user didn't print anything, that we want to return. By the way, yeah, just to make sure. So if I not only, so let me print something to make sure that I get here when I don't provide any input. So let's say this is just for debugging quickly. Move SC. Let's put the intro, just whatever string. I don't care what string I call. Print string. So it should be printing the intro. If I don't print anything, it doesn't. So do I get there actually? Okay. Okay, guys. So just made some weird crap here. Sorry for that. So if we hit enter, I just jump in back to shell loop. I've uncommented the jump to search file, but I didn't do anything yet here. So yeah, okay, let's try again. So yeah, I just didn't input anything, and it now prints me the welcome message, which means like, which we asked it to do basically. Okay, so this is good enough for now. So we just can say return back to OS. That's okay. Jump equals, just make all the lower cases. All right, great. And so now let's say check the first byte user has entered. Okay. If nothing, then return to the shell, to the main, then return. Okay, and here return to the main OS loop. Great. Okay, so the next thing, we need to keep track of the file list index, and we're going to be using the bx register for that purpose, just like we did in this print file. So this code snippet comes really handy and useful because it was a bit of a preparation for the search routine. So still, it probably made sense to consider. So we initialize this at 0, and here we're having our file list index. So this would be pointing to the first file, to the second file name. So file list. So it would be pointing to the file name. So file name list index. Save. All right, and then it's important part. So remember that the DL register serves to keep track of the sector that we want to associate with a certain file. So just okay. It's not enough just to have, so we'll go to files. This is not enough just to have these names. We need to associate them with a certain sector. So this would be associated with the sector number, I will tell you what. No, hold on a sec. Function 9, memory map. So we have first sector bootloader, then files, then shell. So starting from 4, so snake is sector 4. Okay, I already have this here. So snake is going to be the sector 4. So we need to make sure that DL starts from pointing to sector 3, right? Yeah, because then we will increment this, or no, it should point to sector 4 before execution. Okay, let's start. So move DL 4, sector of the first, let's call it executable, sector of the first executable on the USB flash drive. All right. Okay, and then we have the next game label and jump to the next game. So we're going to be processing them just like we did within the print files loop here. Okay, so here process next file name. All right, so and now, okay, so we do the same thing as we've been doing here. So I'm going to be using AX as points to the first character of the current file name located in the file's ASM. That's pretty it. And then we want to say, so if the file exists actually. So want to say compare AX with no file. Well, actually, yeah, this we can just grab this line as well. So compare AX with no file, with no more files left in the list, and then we just need to. So here we're jumping to return, and well, in this case, jump equals to, let's call it no file found. Okay. Let's say return from procedure. Well, say go to no file found label. Okay, and here no file found, and here move si. We'll now create a new variable, no file found, and okay, just quickly do it, point si to no file found variable. Okay, and call print string print error message. And here within the messages we can say, well, let's actually call it error no file db no file found. New line character, carriage return, 0 terminating character. So yeah, let's call it error no file. Okay. What else? And yeah, then we need to increment bx by 2. So I say add bx 2, and here that's the offset. You remember we've been doing this. So point bx to the next file name. Okay. So point bx to the file name, and also we need to increment our sector, because in order to associate the certain sector with a certain file name. So now we have dl being associated with the first file, bx holds the 0 offset, then bx would be equal to 2, dl equal to 5, then bx equal to 4, dl equal to 6, and so on. So we need to keep track this synchronization between the sector and the file. So I also want to say increment dl, and here let's say sync, let's say associate well, let's say want to sync the file name with a corresponding sector on the USB flash drive. So it's clear, guys, right? So the DL holds whatever sector we have. So bx equals to 0, this points here, but the sector is 4. Okay, then bx equals to 2, points here, the sector, the DL is 5, then bx is 4, and DL is 6, and so on. Okay, and yeah, also the execution rate. So hold on a sec. Okay, so here, okay, the next step. So yeah, now the most essential thing, we need to call compare strings, and we want to compare user input with the corresponding file name. Okay, and you remember that the compare string sets the CL flag, so returns true in case of if the string match, if the user input would match. So the user input, and to SI we're putting the AX, and AX is now equal to the file name. So this is how it works. So now we want to compare the CL. So compare CL with 1. So if user input matches file name, then execute corresponding file. So in this case, I want to say jump equals to here would be the label execute, the local one. Okay. Execute, and here we want to call our execute. Okay. Hold on a sec. Oh yeah, it calls the read sector, and within the read sector, okay guys, sorry, just got a bit overwhelmed. Hold on a sec, let me just figure out. Okay, finally got it. So instead of having the fixed sector to execute, here we want to use the DL instead. Okay, here we want to use the DL. Right now it should be fine. So call execute. All right. Execute file. That's pretty it. Yeah. Just to make code a bit more pretty, let's go like this. Return. So here we call execute. And then we don't need anything because after the game, the game would be kind of jumping back, so we don't care about the return statement. And yeah, by the way, another important thing, I thought that we don't need to deal with a stack, but I was horribly wrong because actually, yeah, as far as I'm aware, when we call a function, this puts the certain address where we currently are, the instruction pointer to the stack, right? There should be something like that. I need to learn about that more precisely to be confident enough to talk about this. But anyway, so we'll need the stack. But when we will be returning from the game, we don't care if the stack is smashed or something, because we're going to be reinitializing that. Okay, but okay, just hold on a sec. I want to check one little more thing. You know what, guys? I think that yeah, we may do this a bit different, a bit easier. So instead of being bothered with this unnecessary calls, what if we just jump to the actual location of the execute, right? And that's pretty it. So execute file. Okay. Let's say execute binary corresponding to the file name. Execute the file name corresponding binary file. Okay, I think this is the case, right? return. Okay, no file found. Great. Okay, let's actually forget the pretty print and let's keep it like this. Okay, so what else? So call compare strings if the CL is equal to 1. Okay, we go into jump equals to execute. What else? Yeah, and then we go to the next game. This should be it. Well, probably I made some mistakes, but I really hope so. So what do we expect now? Now we expect to print game not found. By the way, hold on a sec. The game not found. Print string no file found. No file. Okay, so we expect to see that no file is found if we print some gibberish, and if we print the correct file name, we expect that file to be executed. So one of these files that would be associated with a certain sectors where the games are. So if I type snake, it should run snake. If I type Tetros, it should run Tetros, etc. All right, so hold my breath, and here we go. And we got compilation errors, I believe, like assembling errors, search file error, no file undefined. Error, no file. At line 80, no file found, undefined. Oh my god. Oh my god. Line 80. Jump equals to, oh, error no file. Hold on a sec, how did I? Oh, error no file. Okay, that was copy. Jump to no file found. And here, yeah, just messed up things. Error no found, because error no found is the variable name containing a message that we want to print, while no file found is the label where to jump on a condition if the file is not found. Okay, so let's go again. Something still wrong. Oh my god, symbol error no found. 89. Error no file, I guess it's called. Yeah. Okay, so I print gibberish, file not found. And why do I stuck here? It's probably I forgot to return. Okay. Yeah, I want to return. So I would either execute, or if no user input it, then I return. Yeah, so here I want to return as well. Okay, I could have actually say jump to return, but no, let's keep it like this. And if I execute, then I make a forward jump, so I don't care about that return anymore. Yeah, do I? Oh, this gets a bit overwhelming. Okay. Okay, something's going horribly wrong. I'm sorry, guys. Yeah. So where do I call the search file? Oh, I don't want to jump equals, I want to call. Yeah. Oh my god, guys, just hold on a sec. I need to debug this stuff because, yeah, otherwise it goes crazy completely. Okay, so one of things I've realized here, so we can call, it just calls every time. So we need to stay still, jump equals, let's create a label, search. and go to like, how did I go to search file? Go to, yeah, go to search label, and here let's provide the search label, and we call the search file. Okay, at least now it should be done conditionally. Okay, it doesn't print if the gibberish is happening. Well, but at least, yeah, at least it doesn't stack in one place. And probably here, sorry guys, I'm not sure. It goes a bit different compared to what I've been doing, compared to what I've been preparing, so I'm forced to go for a bit of a live coding here, which is not the best ever thing when you're coding in assembly. But at least this is how the process works. This is how the process looks like. Oh, and yeah, I did put here, thanks for liking the videos, guys. For debugging purposes, I just put here return statement. Yeah, so get rid of this. All right, so no file found. Great. I want to print this from the new line, so no file found. So let's say 10 new line carries return, then print. Okay, and probably I don't need it here anymore. Okay, print in gibberish, no file found. Great, and snake. And we get entries. It's a bit unfortunate, probably because of smashed sectors. Okay, so we don't return from the game for now. It's not a big deal. So let's see. We actually have the tetros when we print snake. So that means we need to set DL to one number less. Oh my god, where did I set the DL? Yeah, DL should start from 3. Save. Run. Snake. Yeah, now we got snake. Great. And bricks. Now we got bricks. And should escape. Okay. And tetros. And doesn't escape from here for now. Okay, guys, so congratulations. Yeah, so what was wrong with this DL here? Let's see. So DL equals to 3. So we increment the DL, and then we compare strings. Yeah, that's the reason. So yeah, so first, if I just thought that we increment DL after searching for a game, but we do it before, hence yeah, that's pretty natural that we increment DL. DL now equals to 4, then we compare strings. So 4 is associated with snake, 5 is tetros, 6 with bricks, just like we have in our memory map. Okay, so now yeah, before we end with this video, I want to check out a few more things. So this is getting a little bit too complicated. I'm just a bit confused with this sort of return statements that we made. So let's say, so what happens in the loop? What happens in the loop? So if the enter key, so we jump equals to search, right? And here, okay, So we call in search. So let's say user didn't type anything or typed the name of the file that doesn't exist. In both cases, we have return. So we don't have return from after the execution actually, but we do return after either no input or a run input. So let's try to figure out what happens next. So we call search. Okay, and then we probably return here, right? And then we automatically jump to the next loop. So I guess, yeah, if it was kind of before, it would be kind of like a raising char, right? Or okay, doesn't matter. So it seems like we do jump to the next shell loop. Yeah. I just want to print something here. So let's say print. Move aside. Just want to figure out the program flow. It's a bit difficult to debug, but anyway. So let's print the intro in case if we have no input or if we have the run input. So I just want to see if it gets here, and that probably starts the loop from scratch. And call print string, save. All right, so type gibberish, no file found, and then we print this, and then we start a new one. Okay, and here the same. Yeah, we just don't print no file found because we just return straight ahead. Okay, great. So oh my god, I hope, guys, I really hope that after calling the search file and returning, we actually jump back to the shell loop. Now, things are getting a little bit different when it comes to the execution, and this is going to be the topic of the next tutorial. But let me make a little trailer in that regards. So we call in the search file, right? And if this happens, that after a string comparison, we actually do have the CL equals to 1, which means that compare strings has set this to true because we have the string matching, right? So in this case, we're not calling, but we're just jumping. So we're not putting anything onto stack. We just jump to execute, which is here, and here we initializing the boot sector. And by the way, hold on a sec. I want to replace this with the boot sector 7C0. Do we have that? Yeah, boot sector address. I want to reset this. Execute boot sector address. Okay, initializing the extra segment, the local offset. Okay. CL becomes, so literally which sector to read is whatever stored at DL that associates the file name with the physical location of the file on the USB flash drive, right? And then we call the read sector, and if it doesn't work, then we should stuck forever. Okay, otherwise we jump, we're making a far jump. Man, where is that? Execute. Otherwise we make a far jump to the boot sector, and there we assume that the game initializes everything from scratch as if we've just boot our computer and does what it does, all right? And then it's already the matter of the game to drop back to the shell. Now, a natural question is arising here. So what happens? So I just wondering, is there any call? So as far as, do we call the, no, we don't call the execute. Hold on, guys. I just need to figure out one important thing here. So we jump equals to search. So we first call. So yeah, this call. So here is the deal. So we call search file routine, but it returns in case if we didn't find anything, in case if we didn't type anything, okay? But it doesn't return in case if we successfully execute the game. So we jump equals to execute. So this means that in the stack we will still be having the address from where we call the search. In this case, so if we reset the stack pointer later on, that means that we are no longer would be able to return, right? But we don't need to, because running a boot sector game is not made via call or via var call. It's made via var jump. And let's say if we reset the stack in the shell, right, then we will be able simply to not taking care about what the value would have been in the stack segment. So we just reset the stack segment again. We just put the stack pointer, the very first element. And yeah, so I mean, like for the next iteration, it would feel like we have boot this from scratch. So it won't remember like the previous game that we did gonna run, and from the game we're gonna be just making a far jump back to where our shell is. So that's what's currently in my head. Well, maybe not the best ever practices from kind of like the design perspective of how this might have been done, but I don't really want the operating system be responsible for all of these processes, and I want the game to be as standalone as possible, and not only the game, like whatever apps, whatever commands. So if the command works, it gives the output, and then it just jumps back to the shell, and we restart from scratch. It might not be that great for commands like list, however, because let's say we do so, and if we jump back here, then we reset this, then we set the screen, and so yeah, well, in that case we'll need to wait for user input or something. Okay, so as you can see, I currently have lots of design issues that I really need to think about, but just wanted to show you how this design kind of like process happens inside. Okay, so yeah, let's go for one last demonstration. Yeah, for those of you who click at the very end of the video to see what this guy eventually came up with. So here is what this guy Again has eventually came up with. So I have a shell. If I type gibberish, then I'm getting the error message like no file found. However, if I type whatever name that corresponds to the certain game, I will get this game running, which is the core essence of the shell itself. So if I say snake, I can now play the game of snake. Okay, great. And so on. So I've already modified the snake to jump back if I press Q. Okay. By the way, doesn't mean that. Okay, just forget this. The next thing, so if say I type bricks, I can play this Arcanite type game and go back. Okay, if I use snake again, so this still should be working, so it jumps back to shell. I just don't remember what exactly happens within the game because I could have changed the address of where the shell is loaded, so I need to check that out as well. Even though it looks exactly like it should be, I'm not sure whether this happens due to what I've written or due to some weird errors I could make. Okay, and Tetris doesn't yet allow to go away from here, right? So it just allows to play and stuck forever because I didn't yet adjust the game on its own, because obviously the game doesn't assume any operating system, so when the game ends, it doesn't perform any jumps or not literally doing anything. So that's pretty how it works. Okay guys, so I can say that today we've reached one of the most essential milestones in development of our operating system, because this is the just essence of what the operating system shell is going to be doing. It has to run certain games or apps based on the user input. So I don't want to say that we have a file system, but if we can say that actually associating a certain sector on the physical drive, on the USB flash drive in our case, with a certain file name can be actually treated as the file system. Well, in this case, we can say that we do have a file system. Otherwise, I wouldn't say so. So that's pretty it. And let me just play Tetris a bit more. And yeah, another important goal that was set initially before this project was on the cards was to be able to run boot sector games without a need to write a new flash drive, right? So they all live in the single, they all live within the single image. Okay, stored to the written to the USB flash drive. Sorry, I just wanna probably, oh man, I'm losing, horribly losing. Yeah, I need to practice my Tetris skills definitely. Well, okay, but anyway, I hope you got the sense from this, and I'll just think around some possible potential pitfalls here, and once I came up with a reasonable solution that would be satisfying me at this point, I will share that with you guys. And again, like as far as we did involve function calls, so still we need to implement the stack. We should have done this at the very first step actually, but I just thought I don't need that, but it turns out that I did. Okay, so the next video would be dedicated to what the stack is, how it works, and how to initialize the stack segment and the stack pointer. Sorry for doing this a bit too late, but I hope this is gonna be fine. Well, okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.